Cool, shall we have a look at an example then? So now we've kind of understood the idea of taking roots of complex numbers. Let's try this one. So I've got my favourite complex number on the screen, 1 plus I. On the screen, I'm so used to working online, on the board. 1 plus I, and can we find the cube root of z? Okay, so first things first, what do we need to do? What's the issue with this form at the moment?
Transform into gradient.
Yeah, good, so we need a modulus and argument, right, so either Euler or polar form. Let's do that. Hopefully you're fairly used to this complex number by now. You find r is root 2 and theta is pi by 4. Cool, so shall we work with Euler form, just because there's less writing to do?
Yeah.
Okay, so let's do z must be equal to then root 2 e to the pi by 4i. Okay, so we want to take the cube root of z. So are you happy that if I wanted to turn that into a power, it would be to the power of a third? Yeah? Cube root of z, z to the power of a third. Happy with that?
Yeah.
Cool. So if I want to take the third, or z to the power of a third here, okay, I go z to the power of a third, just using de Moivre's theorem, root 2 to the power of a third, e to the power of pi by 4 times by a third, lots of I. Happy with that?
Yeah.
Yep. Okay, let's do a little bit of simplification. First of all, treat that root 2 as 2 to the power of a half. That's going to make things a little bit easier. And then, obviously, e to the power of third times by pi by 4, pi by 12, lots of I. Okay, what's this? 2 to the power of a half to the power of a third.
6.
Yep, 2 to the power of 6, good. So you're happy if I write that as a 6th root of 2?
Yeah.
Okay, so to be honest with you, that is my first root. If you get that far in the exam, this is maybe like a 6-mark question, you're going to get 3 marks, right? You've done the conversion, you've used de Moivre's theorem successfully, and you simplified to find the first root. Okay, so that's 3 marks already in the bag.
Okay.
Okay, but are we done?
No.
Why not?
Because we have 3 points.
Good, exactly. We're expecting 3 roots, right? So this is only one of the roots, okay? We need to find the other ones. So actually, I'm going to call this one Z1. Okay, Z because it's our complex number and it's the first root, so Z1. Okay, it's totally fine. So how am I going to find the other 2 roots then?
Using Euler form?
I like the idea of using rotation. Sorry. Okay, so we could use polar form, but I think stick with Euler form. Yeah, that's fine. So yeah, we're going to have to rotate.
I just don't know how much I can.
Okay, what's a full turn?
Pi by
The full turn is 2 pi radians.
pi,
We know that our roots are equally spaced, hence it'll be 2 pi by 3. Yeah, because there's 3 roots. Okay, so yeah, we'll put up.
that, right?
Yeah, perfect.
Plus 1 and then plus 2.
Yeah, so it's 2 pi divided by the number of roots, so 2 pi by 3. Absolutely, the modulus stays the same. We don't need to change the modulus, it stays the same as we saw on that animation on the screen. So all we're going to have to do is take that pi by 12 where we're at the moment and just rotate by 2 pi by 3, okay, to find the second root. So here we go. Z2, keep the modulus the same. Okay, pi by 12 plus 2 pi by 3. Would you be happy? That is going to be 9 pi by 12, yeah?
Yeah.
God, making me do maths early in the morning. All right, and then Z3, if we take 6th root of 2, e to the power of 2 pi by 12 plus, that's going to be 10 pi by 12 or 5 pi by 6, I think. Hang on, what?
And the second one,
That's not right, is it? What did I say? Try that again. Pi by 12 plus 2 pi by 3.
correct, I think.
It's 9 pi by 12, isn't it?
Yeah, yeah.
That's what I said, yeah. For some reason I wrote 2 pi by 12. Okay, let's try that again. 9 pi by 12 plus 2 pi by 3 is going to be 17 pi by 12.
Yeah.
Lots of I.
Yeah.
Those are my 3 roots, okay? Now again, I am totally fine if you want to leave your roots like that, okay? So either like that, you could do it in polar form if you really wanted to as well. So yeah, if you did it in polar form, just basically whatever modulus argument form you use, either polar form or Euler form, it's fine to leave your answer like that. I'm not interested in you converting it back again. It doesn't really add anything to the assessment. So yeah, 6-mark question, where are the marks? Well, first of all, number 1, finding modulus and argument. Number 2, using de Moivre's theorem. Number 3, successfully simplifying to find Z1. Number 4 will probably be figuring out the spacing. Number 5 would be realizing you had to just keep the modulus the same and add that spacing onto the argument. And number 6 would be all of the roots there. Okay? So you can kind of think about how I'm going to be awarding marks this. What are the assessment criteria that you need to think about here? It's a good way of going about it.